Hello and welcome to the video on section 19.1, radical expressions and functions. A few definitions to go over here first. A radical, that is the symbol to denote taking a root, and the radical is going to look something like this. Sometimes they'll have a little number out front here, just depending on what root we are taking. A square root, that's a number that produces a specified quantity when multiplied by itself. This is the one that you will see most often. The square root, typically, we don't write the little number here in between the little crevice here. So typically, there'll be a number there. If it's a square root, there's not. If you would like to write one there, you can always write a 2, but it's not necessary. Cubed root, that's a number that produces a specified quantity when cubed. We're going to denote a cubed root with the radical symbol and the little 3 in the crevice. When it produces specified quantity when cubed, it just means multiplied by itself 3 times. The radicand, that's a number or expression underneath the radical. So if we were to have the square root of 4, okay, the 4 would be the radicand. And the root is a number in front of the root. I'll show a little example here, would be where the x is. Right? So sometimes it'll be 3, 4, 5, 6, just whatever root we're taking. So if we'll move on, we can go into a couple examples here. We can see our first example is the square root of 16. Well, we know that 16 is 4 squared. So we are looking for the square root of 4 squared, which will be 4. So we can say the square root of 16 is 4. The same here with 81. We know 81 is 9 squared. So when we take the square root of 81, we can say that's the square root of 9 squared, which is just going to be 9. So here we're given a fraction underneath the radical, and there's 2 ways you can go about this. I personally like to separate it, so I like to rewrite it and have the roots in the denominator and the numerator. Or you can just take the square root of both. I like to write it out like this. It makes it easier for me. I know that then the square root of 25 is 5 because 5 squared is 25, and the square root of 36 is 6 because 6 squared is 36. Number 4 looks a little bit different here. We got a negative out in front. That is not going to deter anything. We're just going to keep that negative. Okay. So we know that 121 is 11 squared. So the square root of 11 squared is 11, and that negative just stays out front. Same thing here with a 5. So we'll leave the negative out front. We know that 400 is 20 squared, excuse me. So the square root of 400 will be 20, and the negative stays out front. On number 6 here, we have something a little bit different. We have a negative inside the radical. Okay? Since we're dealing with a square root, anytime you're dealing with an even root, there's not we can't have a negative inside because we cannot square anything and have it become negative. So for this one, there is no solution. Actually, what we can put is no real solution, as we'll find out later that there are some imaginary numbers that we can use to figure this one out. But that's for another day. Going to a couple more here, we have we're given a function. Given the function f of x equals the square root of 4x minus 3, and we want to find out what the function is when f is 2, or when x is 2. So the function at the value of 2, and then all we're going to do is just enter a 2 anywhere we see an x. So this can become 4 times 2 minus 3. And we know that 4 times 2 is 8. So now we have 8 minus 3, and we know that 8 minus 3 is 5. Okay. Now if we are asked to give an approximate value, we can plug this into our calculator and then round to the necessary decimal points that we're told. If they want an exact answer, we're going to leave it as a square root of 5. In this situation, they don't ask, so we're just going to leave it as a square root of 5. For problem number 8, given another function, f of x equals negative 2 times the square root of x minus 1, and we want to know what the value of that is at f at 10. So once again, we're going to copy down the problem, and anywhere we see an x, we're going to insert a 10. Okay. Well, 10 minus 1 would be 9. Square root of 9 is going to be a 3. And we know negative 2 times 3 is negative 6. So f at negative 10, or excuse me, f at 10 equals negative 6. Move on. We've got, we talked a little bit about earlier about approximating a square root. It says plug the root into your calculator using the square root button. And the square root button is going to look something like that. Now they might have that 2 there, they might not. It just depends on your calculator and which style you have. So here we are given the square root of 200. So if we would plug that into our calculator, get my calculator out here and check this out. If I can find it, there it is. So we are getting that this is going to be 14, and it's going to give us a whole lot of decimals. So this is 14.142135 6237 3095, and it keeps going. Ooh, that doesn't look like a 3 there. Let's fix that real quick. Wow, it's not letting me write a 3 very well. Let's try this one more time. 3095 were the last few, and it goes on forever and ever, because this is not a rational number. So this is our approximation. Anytime you're asked to approximate, it's going to typically ask you where to round it a certain spot. In this example, it doesn't give us a spot, so let's just round it to the nearest thousandth. Okay, we know that the thousandth is going to be the 2 right here. So we look at the number after the 2. Is it 5 or greater? It is not. It's a 1. So we're going to leave that as 14.142. And that would be our approximation. And typically that is denoted with kind of a squiggly looking equal sign. The next part we can look at is finding the root of variables. Note that for any real number a, so the square root of a squared is going to be the absolute value of a. All that is basically telling us is we cannot take the square root of a number and get a negative number. So in this point, if a was negative 1, negative 1 squared is 1, and so the square root of 1 would be 1. So a was negative 1, so the absolute value of negative 1 is 1. Easy thing to remember. Take the square root of a number, take any kind of even root of a number, we're not going to get a negative number. So variables, we have to make sure we denote it with the absolute value. So in our example here where they give us the square root of 16t squared, I like to break it up. So I'm going to do the square root of 16 times the square root of t squared. Okay. And we know we can do this because if we just multiplied these back together, we would get the square root of 16t squared. So as out before, we know the square root of 16 is 4. Okay. And then square root of t squared is just going to be t, but we have to denote that it's the absolute value of t just so we know that we're not going to get a negative there. If we move on, we're going to look at some cubed roots and some higher order roots. So as we recall from the first page of our definitions, we know that we were defined a cubed root as a number that produces a specified quantity when cubed, or multiplied by itself 3 times. So a lot of times, easy way to look at this, if it doesn't jump out at you that 8 is 2 cubed, we can take 8 and we can do a little factor tree. When we do this, we find out that 8 is 4 and 2, then 4 is 2 and 2. Know that 8, if I can write correctly here, 8 equals 2 cubed. And if we're going to take the cubed root of 8, it's the same as taking the cubed root of 2 cubed, which then is going to be 2. Same here with the 125. Okay, we know that 125 is 5 times 25. 25 is 5 times 5. So 125 is going to equal 5 cubed. So if we're going to take the cubed root of 125, we are going to know that that is 5. Here's one a little different. It's a cubed root of negative 125. As we recall earlier, we said we cannot take we cannot have a negative root of an even root. The cubed root, though, is an odd root, so we can do that. So one way to look at that here is if we have, or make a factor tree, I have negative 125 broken down into, wow, I need to learn how to write here. Get back to that. Negative 5, wow, it's doing it again. This is fun. Sorry about this. My little pad here is a little issue. So we know that negative 125 is the same as negative 5 times 25, and I can simplify 25 to negative 5 times negative 5. So I know that negative 125 is negative 5 cubed. So if I'm going to take the cubed root of negative 125, I know that that is going to be a negative 5. This is the only time that you are going to get a negative out of a root, is if it's an odd root and it starts with a negative. I'll go down to the next example. It's the 4th root of 16. We haven't done a 4th root yet, but as you can imagine, it's going to be basically the same thing. So if I want to break this down, the 16 down, I want to look for groups of 4. So I know that 16 is 4 times 4, and then 4 is 2 times 2. So 16 equals 2 to the 4th power. So if I'm going to take the 4th root of 16, that's the same as taking the 4th root of 2 to the 4th power, which in turn is 2. Our 4th root to look at here, we're going to look at the 4th root of 256. So we need to figure out the prime factorization of 256, and we're looking for groups of 4 once again. So with 256, I know 2 is going to go into 256, and it goes into it 128 times. I know that 2 goes into 128 64 times. I know that 2 goes into 64 32 times, and I'm running out of little room, so we're going to go sideways. 2 goes into 32 16 times. 2 goes into 16 8 times. 2 goes into 8 4 times. Then 4 is 2 times 2. So we have 2, 2, 3, 4, 5, 6, 7, 8 2s. So I know that 256 is 2 to the 8th power. So if I'm going to have the 4th root of 2 to the 8th power, I can break that up into the 4th root of 2 to the 4th power times the 4th root of 2 to the 4th power. Each one of these is going to equal 2, and 2 times 2 is 4. So we know that the 4th root of 256 equals 4. Now if you didn't do your equation the same way as this, that is fine. As long as you're finding groups of 4, you're going to be in good shape. Someone may have started here with a 4, and that's how you would end up just getting 4 to the 4th power. And so that is the end of the video for section 19.1 on radical expressions and functions. Thank you very much, and